Our objectives in this lesson are the following. Apply the formula in determining the margin of error. Compute for the length of the confidence interval. We have three conditions here. When the population standard deviation is known, when the population standard deviation is unknown, and when we use the empirical rule. And last one, to compare confidence level and confidence interval length. Let's have a quick review of our previous lesson. Let us apply the missing data in this table. If the confidence level is 0.90, the alpha level is 0.10. And the z-value or critical value or confidence coefficient is 1.645. If the z-value is 1.96, then the confidence level is 0.95. The alpha level is 0.05. If the alpha level is 0.01, then the confidence level is 0.99, and the corresponding critical value is 2.575. Have you ever wondered where these values came from? Let me show you. Let us take an example, the 95% confidence level. 95% in decimal is 0.95. Dividing into 2, each area from the mean is 0.475. Now, let us look for this area in our z-table. It is here. Now, let us determine the corresponding z-value. It is 1.9, and the hundredths digit is 6. That is why we have 1.96. Since the normal curve is symmetric about the mean, then this is also 1.96. Only negative because it is on the left side of 0. 95% confidence level means that if we calculated confidence interval from 100 different samples, about 95 of them would contain the true population parameter. Margin of error is just like a confidence interval. It reflects uncertainty on either side of the estimation of the statistic about the parameter. In my previous lesson, I have already introduced margin of error, but it was provided in the examples. Now, we will be computing margin of error in this lesson. Let us also recall the empirical rule. The empirical rule, also known as 68, 95, and 99.7% rule, states that 68% of the distribution falls within one standard deviation away from the mean. 95% falls within 2 standard deviations, and 99.7% falls within 3 standard deviations away from the mean. Confidence interval is the range of values that hopefully contains the true parameter, let us say the population mean. The middle value of the confidence interval is the sample mean plus the allowance on either side for uncertainty. Therefore, confidence interval quantifies the uncertainty of estimations. Confidence interval is first introduced in empirical rule. Here are the interval estimators that we are going to use using empirical rule. Don't get intimidated with these formulas. These are just the same as computing for the lower and upper limit of the confidence interval, which is the heart of our discussion today. Let's have an example. A random sample of 50 MADIS senior high school students have a mean height of 67 inches with a standard deviation of 2 inches. Construct a 95% confidence interval and make a conclusion for the mean height of all MADIS senior high school students. So first, let us identify our given here. We have random sample of 50, so n is equal to 50. Have a mean height of 67 inches. This mean height refers to the sample, so this is the sample mean. And a standard deviation of 2 inches, also referring to the sample, so sample is standard deviation. 95% confidence interval, so our confidence level is 95%. If it is 95%, then we are going to use this formula in constructing for the confidence interval. This portion here is actually the margin of error, so we can compute first for the margin of error. Let us substitute 2 for S and 50 for N, and this will give us 0.57. Now that we have the margin of error, we can compute for the lower limit, and that is equal to the sample mean minus the margin of error. Let us substitute 67 for our sample mean and 0.57 for the margin of error. And this will give us 66.43. Now let us compute for the upper limit. That is equal to the sample mean plus the margin of error. Let us substitute the values, and this will give us 67.57%. For the confidence interval, it would be mu is less than 67.57 but greater than 66.43. Or you can also write in this way. Now let us make our conclusion. We are 95% confident that the mean height of all MADIS senior high school students is between 66.43 inches and 67.57 inches. For the sake of those who wants to see how this formula works, let me show you. All you have to do is to separate this plus and minus here. So we're going to create one for minus and another one for plus. Then we substitute our values. Sample mean is 67, S is 2, and N is 50. This will give us 66.43. We'll do the same thing on this side, only this time it is addition. And this will give us 67.57. Therefore, the interval is the same like we got earlier. The empirical rule is limited with 1, 2, and 3 as critical values, which stand for 1, 2, and 3 deviations away from the mean. A good confidence interval requires a critical value with more precision. If we want to estimate an interval besides 68, 95, and 99.7%, we can't use empirical rule anymore. As mentioned in my previous lesson, the common level of confidence aside from 95 is 90 and 99%. In fact, we can also compute for other confidence intervals aside from the common level of confidence and the empirical rule. Let's have another example. A random sample of 64 final exam scores were selected. Its sample mean is 84 points. The population is normally distributed with a standard deviation of 16 points. Solve letter A, margin of error. B, construct 95% confidence interval. C, make a conclusion about the population mean. And letter D, compute for the length of the interval. So first, let us identify our given here. We have random sample of 64, so N is equal to 64. The sample mean is 84 points, so X bar is 84. The population is normally distributed with a standard deviation of 16. So this is the population is standard deviation. Sigma is equal to 16. We are asked to construct 95% confidence interval, so our confidence level is 95%. So this is an example of sample size greater than 30 and the population standard deviation is known. In this case, we are going to use the z-table. So once again, the common level of confidence, which includes 95% or 0.95, its corresponding critical value is 1.96. Now let us solve for the margin of error. So C sub alpha over 2 is 1.96, our sigma is 16, and our N is 64. This will give us 3.92. Let us solve for the lower limit, that is just the sample mean minus the margin of error. Let us substitute 84 and 3.92 here. And this will give us 80.08. Now let's have the upper limit. That is the sample mean plus the margin of error. Let us substitute the values. And this will give us 87.92. Let's construct the interval. The population mean is less than 87.92 but greater than 80.08. Or you can also write in this way. Let us now make our conclusion. We are 95% confident that the population mean score is between 80.08 and 87.92. And finally, let us compute for the length of the interval. This is just the upper limit minus the lower limit. Let us substitute. The upper limit is 87.92 and the lower limit is 80.08. And this will give us 7.84. Another example. In a random sample of 20 customers at McB, the mean waiting time to order is 95 seconds and the standard deviation is 21 seconds. Assume the wait times are normally distributed. Make a conclusion on the mean waiting time for all customers at 90% confidence level. So again, let us have our given first. We have random sample of 20, so n is equal to 20. And the mean waiting time to order of the sample is 95 seconds. So x bar is equal to 95. And the standard deviation of the sample is 21. We are asked to construct a confidence interval at 90% confidence level. This is an example of sample size less than 30 and the population is standard deviation is unknown, but the distribution is normal. In this case, we are going to make use of t-distribution. If we are going to use t-distribution, then we have to determine the degrees of freedom. And that is just equal to the sample size minus 1. So 20 minus 1 is equal to 19. With confidence level of 90% and degrees of freedom equal to 19, let's have our t-table. So confidence level 90%, let us box this column here. Degrees of freedom is 19. Let us box this row. And the t-value that we are looking for is 1.729. Notice that instead of z, we have t here because we use t-table. Let's compute for the margin of error. It is just the same as the margin of error using z-distribution. Only this time, you will replace z with t. And since we do not have the population standard deviation, the best estimator for that is the sample standard deviation. So we will replace sigma with s. Let us substitute our values. 1.729 for t sub alpha over 2, 21 for s, and 20 for n. And this will give us 8.12. Now let's have our lower limit. That is just the sample mean minus our margin of error. And this will give us 86.88. This time, our upper limit, sample mean plus the margin of error. And this will give us 103.12. Let's construct our confidence interval. So the population mean is less than 103.12 but greater than 86.88. Or you can also write in this way. Let's have our conclusion. We are 90% confident that the mean waiting time for all customers at McB is between 86.88 and 103.12 seconds. When we are making our conclusion, we are making inferences about the population. That is why we have here for all customers. Another example, a random sample of 60 students in Bright Senior High School were selected. Their standard deviation on 40 item summative test in statistics and probability is 5 points. Determine the margin of error and compute the interval length of 99% confidence level. Our given here, we have random sample of 60, so n is equal to 60. The sample standard deviation is 5 points, so S is equal to 5. This 40 here is just a description of how many items are there in the summative test. Another given is 99% confidence level. So this is an example of sample size greater than 30, but the population standard deviation is unknown, so we're going to make use of the sample standard deviation. Even though there is nothing mentioned that the distribution is normal, but with sufficiently large sample size, CLT tells us that the distribution will be normally distributed. Therefore, we are going to make use of z-table. 99% confidence level or 0.99 has a critical value of 2.575. Let us compute for the margin of error. Let us substitute our values here, 2.575 for C sub alpha over 2, 5 for S, and 60 for N. And this will give us 1.66. Since we do not have the sample mean, we cannot compute for the lower and upper limit of the interval. But still, we can compute for the interval length. And that is using the formula, length is equal to twice of the margin of error. Let me explain this. Consider this as the confidence interval and this is the middle value or the sample mean. Now, from the sample mean to the lower limit is the margin of error. And from the sample mean to upper limit is also the margin of error. So the confidence interval length is equal to twice of the margin of error. So L is equal to 2 times 1.66 and this will give us 3.32. Another one, 25 young professionals from ABC Corporation were randomly selected and their mean IQ is 110. It is known that the standard deviation of IQ is 15. Assume that the distribution is normal, make a conclusion on the mean IQ of all young professionals in ABC Corporation at 92% confidence level. Let's have our given first. We have here 25 young professionals, so our N is equal to 25. And their mean IQ is 110, so X bar is 110. It is known that the standard deviation of IQ is 15. So this 15 here is the population is standard deviation. So sigma is equal to 15. And 92% confidence level. This is an example of sample size less than 30, but the population is standard deviation is known. In this case, we are going to use the z-table. But 92% is not one of the common level of confidence. So I'm going to show you how we are going to get the critical value corresponding to 92%. So 92% or 0.92 in decimal when divided into 2 is 0.46 on each side from the mean. Let's have our z-table. Let us find 0.46 and the closest one is 0.4599. Let's determine the z-value. So we have here 1.7 and the hundredths digit is 5. So we have 1.75 here. C sub alpha over 2 is 1.75. Let's have our margin of error. Let us substitute our values here and this will give us 5.25. Now for the lower limit, that is just the sample mean minus the margin of error. And this will give us 104.75. For the upper limit, the sample mean plus the margin of error, and this will give us 115.25. Let's have our interval. Mu is less than 115.25 but greater than 104.75. Or you can write in this manner. Let's have our conclusion. We are 92% confident that the mean IQ of all young professionals at ABC Corporation is between 104.75 and 115.25. Once again, if you are making conclusion, then you are making inferences about the population. So we have here all. So it pertains to the population. Let us do extra challenge. Father's Day is approaching and Michelle wants to surprise his father with a new leather belt. Upon canvassing 30 belts, she found out that the average price is 900 pesos with a standard deviation of 150 pesos. Construct a 90%, 95%, and 99% confidence interval. Let's have our given. So we have here upon canvassing 30 belts. So we have N is equal to 30. Found out that the average price is 900. So this is the sample mean. And the standard deviation of 150 referring to the sample. So this is sample is standard deviation. Let's have first 90% confidence level. For 90% confidence level, our critical value is 1.645. Let's determine the margin of error. Let us substitute our values here, and this will give us 45.05. For the lower limit, that is the sample mean minus the margin of error. So 900 minus 45.05, and that will be 854.95. For the upper limit, that is the sample mean plus the margin of error, and that is 945.05. Therefore, the interval is mu is less than 945.05 but greater than 854.95. Now, let's have 95%. For 95%, our critical value is 1.96. Let's solve for the margin of error. Let us substitute 1.96 for our C sub alpha over 2. 150 for S, and 30 for N. And this will give us 53.68. The lower limit is the sample mean minus the margin of error. And this will be 846.32. Upper limit is the sample mean plus the margin of error. And this will give us 953.68. Therefore, the interval is from 846.32 to 953.68. Last one, 99% confidence level. For 99%, our critical value is 2.575. Margin of error, 2.575 for Z sub alpha over 2, 150 for S, and 30 for N. And this will give us 70.52. Lower limit is the sample mean minus the margin of error. 900 minus 70.52 is 829.48. Upper limit is the sample mean plus the margin of error, and this is 970.52. Therefore, the interval is from 829.48 up to 970.52. Let us put in the table our answers earlier. For the confidence interval length, simply subtract the lower limit from the upper limit. So we have here the answers for the interval length. Now, what do you notice? The higher the confidence level, the longer the confidence interval. What else? As the confidence level goes higher, the precision gets lower. For example, let us compare these two. For 99% confidence level, there are more possible values than 95% confidence level. Thus, 99% confidence level is less precise than 95% confidence level. Quick tips: we use this formula for margin of error if our sample size is greater than or equal to 30. Or our sample size is less than 30, but we know the population standard deviation and the distribution is normally distributed. We use T instead of Z if our sample size is less than 30 and the population standard deviation is unknown, but the distribution is normally distributed. If the population standard deviation is not available, then use the best point estimator, which is the sample standard deviation. There are two formulas that we can use for determining the length of the confidence interval. One, upper limit minus lower limit, and another one is twice of the margin of error. The higher the confidence level, the longer the confidence interval length. And as the confidence level goes higher, the precision gets lower. Now, it is time to check your understanding. Pause this video for more time. Let us answer. The standard deviation for human lifespan is 15 years. The average age of 300 Filipinos is 68 years old. Compute the length of the confidence interval using 97% confidence level. Make a conclusion about the mean lifespan of Filipinos. Let's have our given first. Standard deviation for human life span is 15 years. So this is the population standard deviation. 300 Filipinos is our sample size. Average age is 68. So this is the sample mean. And then confidence level of 97%. This is an example of sample size greater than 30 and the population standard deviation is known. So we're going to make use of Z distribution. But 97% is not one of the common level of confidence. So we are going to determine first its corresponding critical value. 97% or 0.97 in decimal when divided into 2 will give an area from the mean of 0.485. We are going to look for this area in our Z table. And it is here. So the corresponding Z value is, we have 2.1. The hundredths digit is 7. So we have 2.17. Let us solve for the margin of error, 2.17 for the critical value, 15 for sigma, and 300 for our n. And this will give us 1.88. Now, for the length of the confidence interval, length is equal to twice of the margin of error. So 2 times 1.88, and this will give us 3.76. Let us solve for the lower limit, that is just the sample mean minus the margin of error. And this will give us 66.12. For the upper limit, we have the sample mean plus the margin of error. And this is 69.88. So we can now make our conclusion. We are 97% confident that the mean life span of Filipinos is between 66.12 years and 69.88 years. Gets? Our next lesson is computing appropriate sample size using the length of the interval.